Hi, I'm Trinity, and I'm going to be presenting on tuberculosis and some of the studies that groups have done to find inhibitors for it. A little bit of background. Mycobacterium tuberculosis is a super deadly disease that claims about 2.5 million lives every year worldwide. Due to its high death rates, tuberculosis is at the center of many studies for researchers trying to find an inhibitor for it. Um, because tuberculosis is a bacteria, it uses the glyoxylate shunt pathway to make ATP. And this is really helpful because us humans don't use this pathway. So if we can target this pathway specifically, um, that'll target tuberculosis cells and not our own. So the glyoxylate shunt uses two enzymes, isocitrate lyase and then malate synthase. Structural studies have shown that malate synthase has a much larger active site and a more accessible one. Malate synthase has been primarily the target for tuberculosis because we can reach this active site, inhibit this active site better. Um, Malate synthase usually binds acetyl-CoA during its normal process, which is aromatic and then has a long chain of ketones. So this group in particular hypothesized that using phenyl acids or PDKAs um, would work similar to acetyl-CoA. As you can see here, this compound, which is a PDKA, has an aromatic group and then a long chain with ketones. Now, this chain isn't as long as in acetyl-CoA. However, they figured that smaller size might actually help it reach the active site um, a little bit better um, and have different interactions. So this group synthesized multiple PDKAs and found that compound 12, which is shown right here, showed the best combination of potency with in vitro PK properties among the PDKA analogs. Because of this, they used this compound for in vivo studies. So what they did was they took mouse models and they injected them with 10 to the fifth colony forming units, which is CFU, of tuberculosis. And then they treated them for 9 days. They did four different doses of compound 12, as we can see here. They did 500 milligrams per kilogram once a day, 600 milligrams per kilogram also once a day, and then 300 milligrams per kilogram twice a day, and 400 milligrams per kilogram twice a day. Um, they used moxifloxacin as a control because this drug has been used in multi-drug resistant tuberculosis cases already. So they figured it would give a good standing grounds for how these drugs work against tuberculosis. At the end of the 9 days, it was found that every single dose of compound 12 did decrease the bacteria count in the mice lungs. Um, A positive number on this chart does show a decrease. I think it's a little bit confusing, could be laid out a little bit better, but uh, it's how it's laid out. So a positive number does show a decrease. Um, we can see here that the 400 milligrams per kilogram twice a day did the best, and it actually had a 100-fold reduction of bacteria from day one to 9. As we can see, the moxifloxacin still did decrease the amount of bacteria in the lungs more. So I think personally that this drug should be researched more and maybe utilized more than this compound 12. However, this does show that PDKAs could be valid therapeutic techniques, and it also shows that malate synthase is a valid clinical target, and we should continue to target malate synthase. Unfortunately, none of the mice were completely cured of tuberculosis, and so more research needs to go into an efficient inhibitor. Here is my full source, and thank you so much.